Okay, so if 115% of a number is 460, what is 75% of the number? So we have 115%. We need to get that into decimal form. So let's divide it by 100. So that brings the decimal points two places. So 1, 2, which equals 1.15. So basically just saying some number, call that num, times 1.15 equals 460. That is our starting point. Then we will divide both sides by 1.15, and our number, which we'll call n, is going to be 400. Once we get 400, we want to know what is 75% of that number. So 0.75 times 400 equals 300. G is your answer. Barb is going to cover a rectangular area 8 feet by 10 feet. So let's draw a picture, 10, 8. With paving blocks that are 4 inches by 8 inches by 2 inches to make a flat patio. Okay, what is the minimum number of paving blocks she will need if all paving blocks will face the same direction? She will not cut any of them. So we need to convert these two numbers into inches. Equals what? 80, 96 inches. And we have paving blocks that are 4 inches by 8 inches by 2 inches. We want to know the minimum number of paving blocks she will need if all paving blocks will face the same direction. So what we need them to either go horizontally up to 96 inches or vertically to 120 inches. Why? Because if all the paving blocks face the same direction, they'll all face this way, right? Or if we wanted them to go horizontally, they can only face all this way. All right, I guess lastly, you could put it on, it's 2 inches, so each one is like this thin. But the question we're asking is, what is the minimum number of paving blocks that we will need? So basically what we want to know is what is the smallest number of blocks we could put in here that will fill up the entire area. So let's do some quick math. So look this way, the brick can be laid out this way by 8 inches, it can be laid out by 4 inches, or it can be laid out by 2 inches. So if I were to lay this brick out where it's 8 inches across and 4 inches down, like this, then that means if we do 96 divided by 8, so I have 12 going this way. And if I go vertically from this point here, because remember this is all the way down, if I do 120 inches divided by 4 inches, because the 4 is going vertical, then what I will get 30 blocks. So that'll be 30 blocks going down. Now, if that's the case, if we have 30 blocks going down and 12 going across, then it just becomes this kind of chart. And it becomes this. And we're just asking ourselves, how many blocks is this? So we just take 12 across, 30 down, 30 times 12 equals 360. Answer choice B. Okay, question 27. So let m and n be two positive integers such that m is less than n. Now remember, they're positive. So really this is 0, m, n. And they're integers, which means they can't be halves. They have to be 1, 2, 3, 4, so on and so forth. So which of the compound inequalities must be true? So what we can do is we can start testing some numbers. So let's make m equal 3 and n equal 4. Okay? So in this case here, if m is 3 and n is 4, let's start with a. Well, if 3 is out here, is the square root of 12 greater, or is the square root of 12 less than 3? Well, it's just 4 times 3, 2 square root of 3. And if you were to do that, which you do have access to a calculator on the exam, so you can always go back and do this, the square root of 3 times 2 is 3.46. 3.46 is not less than 3, so A is out. Now we go towards B. We have 1, again, m and n, 3.46, which we just did. It's less than 3. That doesn't work. Or we have C. We have 3, 3.46. Then we have 4. That works. What about D? We have the square root of m, which is this, is less than 3.46, which is less than 2, because n is 4. Square root of 4 is 2. This does not work because 2 is less than 3.46, so D is out. Then lastly, we have E. So M minus N, so 3 minus 4. Well, this just becomes negative 1. Then we have is less than 3.46, which is less than 4, 5, 6, 7, square root of 7. Well, you can just check this. What is the square root of 7? Well, if this is the square root of 12, the square root of 7 can't be bigger than the square root of 12. That doesn't make any sense. So your answer choice has to be C. So for problems like this, what I would suggest is to plug in some numbers if you don't see a solution right away, and then go straight to testing the answer choices, and there will be only one that works. If there is another that works, quickly test another pair of numbers, just increase them by 1, or if they are allowed to have negatives, do that, but we will go over how to pick numbers in one of our later classes. Thomas and Janelle are playing darts in their garage using the board with the point values for each region shown below. The radius of the outside circle is 10 inches. So this, all the way out here, is 10 inches. And each of the other circles has a radius 2 inches smaller than the next. So this is 8, this is 6, this is 4, and that's 2. Those are all of the radius. Each one gets bigger by 2. 2 inches, 4 inches, 6 inches, 8 inches, 10 inches. All of the circles have the same center. Thomas has only one dart left to throw and needs at least 30 points to win the game. So he needs at least 30. So he has to get, he needs at least something in this range to win the game. Assuming that his last dart hits a random point within a single region on the board, what is the percent chance that Thomas will win the game? So what we need to do is we need to figure out what the total area that we're working with here, and then put the area needed to win. Okay, so the total area is just the big circle. So pi r squared, and r is 10 here. So we have 100 pi. Then on top, what area do we need to win the game? Well, we need at least a 30. And if we see here, the 30, if we go, this is 50, 40, 30. So that is a radius of 6. So we just find the radius of that section there, the area needed to win, because this radius encapsulates everything, the 50, the 40, and the 30. So we do pi r squared equals pi 6 squared equals 36 pi. Then the pi's cancel out, and we have 36 over 100 equals 0.36, 36%. A is your answer.